So, as you probably know, SQL Server 2016 introduced the support for JSON data type, and we will see what it is, how it can be used, and maybe some problems about it. So first, a little introduction about me. So I was a developer, mostly programming ASP.NET using C#, and I started to use SQL Server for version 2000, and I oriented myself to SQL Server development and optimization. So more than 9 years, I'm working for a company named Span, and my current position is senior database developer. I am organizing SQL events in Croatia, like user groups, SQL Saturdays, etc. And also I'm one of co-founders of Data Weekender conference. I am also writing my blog, and here are my contact details if you need me for something. And last year, Microsoft rewarded me with the MVP status for my contributions to the community. Okay, JSON. So JSON is actually JavaScript object notation, and it is a language-independent, open standard format for data exchange between applications and services. You can also store data in JSON format, and it is simple and very popular. It is commonly used for examples in Ajax applications, web services like REST, NoSQL databases, and in simple words, JSON objects are human-readable lists of key-value pairs, like you can see here on the screen, one example of the document. So JSON supports only 3 basic data types, so strings, numbers, and Boolean values, and plus the null value for, of course, representing null values. And all other data type should be casted in one of these. JSON string is a sequence of Unicode characters surrounded by double quotation marks. Special characters must be escaped, of course. And here you can see the escaping rules for special characters. Control characters are always represented by the backslash plus U and the code of this character. So, okay, maybe you are thinking this is like XML, for example. So let's take a look at this also. So here is the representation of customer record in JSON and XML format. And at the bottom, you can see the SSMS result set of the same record, of course. But let's compare this more. So compared to XML, JSON format is less verbose and easier to read. JSON object usually contain less data than XML object, and it's more adequate for network transfers. Also, JSON format contains less text than XML format, and data in JSON format are represented by arrays and objects, while XML is a tree structure. XML can store, of course, more complex data type, and it's more robust than JSON. XML can also store additional informations, and JSON can store only data. So another thing, and this is important, so XML is natively supported in SQL Server because you have the XML data type. And also one more thing, you have, for example, XML indexes, which sometimes make life easier. JSON is stored as nvarchar data type. So as you can guess, it uses more storage. And also with no indexing support, the performance is maybe not optimal. But we will, of course, see later what can we do about that. So the main question, one of them, is why even we should support JSON in SQL Server. And the answer to that question is, for example, like XML, JSON is a standard and it should be supported. Other vendors support it, of course, like Oracle, PostgreSQL, and many others. And some of them, such as, for example, PostgreSQL, are very serious and robust. Many different frameworks in these days use JSON, like web services, applications, etc. Now, when we know why, let's see how. So first thing, how you can convert SQL to JSON. So it's pretty much like creating XML data in SQL Server. You are using for XML clause in the world of XML, and in JSON, you are using the for JSON in the select statement. Of course, there are two modes supported. The first is for JSON auto, and the second is for JSON path. So the first one, for JSON auto, the JSON output will be formatted automatically. And in the second one, the JSON output will be formatted by the query itself, like using aliases. And the purpose of this is to create more complex outputs, like, for example, nested objects. You have three additional options. The first one is include null values, because normally null values are not mapped to JSON property, and then you must use this option if you want to get null values. The root is also similar for XML root option that you can use, and this root options is to add a single top-level element to the JSON output. And the third options is without a wrapper. And with these options, you can format the result as a single object. And usually this session has a big demo, but in 10 minutes we will not have it. So you can try it by yourself. Secondly, we can also convert JSON objects in SQL. And for that, you can use the OpenJSON command, syntax. And it actually returns a normal table that can be used, of course. And depending on the usage, it can return data in two possible ways. So the first is with default schema, meaning that when the schema is not specified, it returns three columns, key value and type. And the explicit schema, this is a user-defined schema, meaning that the return column are defined by the user, also similar in XML world. You have additional three functions. First one is JSON value, and the purpose of this is to extract values from JSON text, and JSON value is used to extract primitive data types. So only null, strings, and numbers or booleans can be extracted by JSON value. Other objects are ignored. For other objects, you have the JSON query, and it is used to extract a JSON fragment or to get a complex value type, for example, array or object. So if you try to extract, for example, a normal string with JSON query, you will get null value. And the last function is JSON. And of course, it checks if the input string is valid JSON data. It returns int value with three states, 1 for yes, 0 for no, etc., and null for null, of course. But it doesn't check actually of the uniqueness of keys. So in the example you can see on the screen, this would be a valid JSON document, of course. So how to solve common problem? Let's find all rows where the city name equals Idaho City. And let's try to find how to improve performance. So this is this normal select without indexes. So first way to do it a little faster is to create a computed column. And to index this column, as you can see, the logical reads dropped from 75 to only 7, and the CPU time was much improved. Second approach is to create a full text catalog and the index on this. With this approach, logical reads were only 2, but sometimes the full text approach is not so ideal because you could get incomplete or wrong data. Also, you will have some problems if you try to search with like, for example. About storage. And what about storage? As mentioned before, JSON is stored as nvarchar max, or nvarchar, sorry, and it consumes more space. This is an example of using no compression, raw page, and in the end, you can see the function compress. It's a newly introduced function to compress data like gzip. And here you can see the data storage. But what about performance? So these are the performance metrics of JSON data with distinct compression used. The worst performing is the compression with the compress function, because the data should be first decompressed and casted, of course. And the compress functions has the lowest number of logical reads, which is nice, but if you have a really strong CPUs, then you can maybe use this approach. So let's finish a little bit. So my answer is yes, absolutely, because in these days, JSON is popular and required, of course. Just take care about performance and correct way of use it. So these are my contact data again, and thank you very much for having me as a speaker.